right, hey everyone. Today we are doing day 3, geometric sequences. Woo!
I mean, it's nothing too exciting. Nothing much harder than what we did yesterday, but
Look, lie to the kids. Lie to them. Tell them it's super hard so then they have to focus.
yes, super, super hard. You want to write down all of the notes. All right. So today we are looking at geometric sequences. We're going to look at writing the explicit equations again. We're also going to show you how to write the recursive equations. Like last time, you're not going to really need to know how to do them. It's just a nice tool to have, but we're going to show you how to do it anyways. And then we're going to look at finding some missing terms. So let's just jump right in. Okay, so a geometric sequence, so arithmetic sequence added something every time to get the consecutive terms, and a geometric sequence has common ratios between consecutive terms. So I'll explain what that means in a second. But we have a sequence where the consecutive terms have a common ratio. Ooh. Wi-Fi is being weird. Okay. The consecutive terms have a common ratio. There. Can they see that?
Yeah.
Okay. It was hidden by your face on my screen. So, all right. Okay, so if we look at a sequence, let's look at 2, let's look at 4, 8, 16. So here, to get to the next terms, we're going to multiply by 2 every time. So 2 times 2 is 4, 4 times 2 is 8, and 8 times 16, or 8 times 2 is 16. So the common ratio here is 2, and we denote that by R. So R would be 2. So essentially, you're just multiplying something every time to get the next term in the sequence.
And if you're ever confused, like this one's pretty standard, like we can see the pattern, like multiply by 2, multiply by 2. You can always take the second term and divide it by the first term, and whatever you get, that's your common ratio. So sometimes it's going to be a fraction. Sometimes we're going to have you guys with like a common ratio of like 3/2 or something. So if you're ever confused, you take the second term, you divide it by the first term and simplify, and that's your common ratio.
Divide by second. Oh. All right, so again, like we talked about yesterday, the recursive equation is really only helpful if you know the previous term. Otherwise, it's going to be really annoying because you have to find every single term to get whatever term you want. So it can be kind of an annoying one. But it is nice if you have the previous term, and it's a nice equation to use. So we're going to show you what it is really quick. So we have an equals an minus 1 times r. So r would be our common ratio like we just talked about. An minus 1 would be our previous term, just like yesterday. And then an would be the term that you want. So nothing too fancy. Pretty much same concept as yesterday, just a slightly different equation. So if we are looking at the sequence that I just gave, so if we're looking at the sequence right here, our recursive equation would be an equals an minus 1, and then multiply it by the common ratio, so we're multiplying it by 2. So there would be our recursive equation for that sequence. Okay, so then the explicit equation, remember, we just take the terms and it's easier to use because you don't need the previous term to use it. So it's a more general equation to use, and our equation for that one is going to be AN equals A1 times Rn minus 1. So N right here, this is the term number. R is the common ratio. A1 is the first term. And AN is the term that you want. Okay, so again, oh, I went off the page. Sorry, guys. Okay, so again, from the equation above, the highlighted blue sequence, our equation would be AN, and then our first term is 2, so that would go right here, times the common ratio, which again is 2, and then n to the n minus 1 is our exponent. So again, nothing too crazy. Anything that I'm missing, Miss Lassie?
No, I think that looks good. I
Cool.
did see someone ask a question in one of the discussion boards yesterday about what does it mean by the nth term? Like on the homework, it said like, what's the nth term of the sequence? See where you have like the a sub n in your explicit equation? Well, like if a problem gives you like a sub 58, then the nth term is like the 58th term.
Mm-hmm.
I don't remember exactly what the problem was on the homework, but like the nth term means like whatever term number it's asking for.
I got a lot of questions on these bottom two right here. So for these, I don't know if this is exactly the one, but this bottom one, this is asking to determine the term number. And so what you're trying to find is what n would be. So that where it says a sub n, you're trying to find what that number would be. And to do that, you need to find the explicit equation, which is what that top line is. And then you plug in 783 for a sub n and then solve for n, basically.
Yeah, that one's just like a work backwards problem.
Yeah.
Scroll up on the homework or down, whatever direction, to the top. Keep going.
Oh, find the nth term.
It says, yeah, like, maybe not. Maybe it wasn't those ones.
It says explicit rule for the nth term, C.
Oh,
right.
for the nth term. Yeah. So that's just like your a sub n.
Yeah. So like where it says A10, it would be the 10th term.
Right,
or the
exactly.
Yeah.
All right, cool. Just wanted to clarify that because I know I saw some people that were confused with the wording. So that's all it means is like whatever term that it looks like, it wants you to find that. Yeah.
And the explicit rule just means the explicit equation. It's the same thing. Yeah. I had a question about that. All right. There's my notes for today. Okay. So I double checked and made sure I had the right sequences this time. So here we go with the sequences. So just like yesterday, we're going to walk through a couple equations. We're going to find the common ratio. We're going to write a recursive equation, an explicit equation, and then find the fifth term of that equation. So for this first sequence, to get to our common ratio, we can take the first term or the second term and divide it by the first term. But I kind of feel like this one's pretty easy to spot. So we're just gonna look at it. So R would be, so I know that our second term is positive. So I know that we have to have a negative number, right? Because a negative times a negative is a positive. And then a negative times a positive is a negative. So to continue this pattern, we have to have a negative number. And to get from 1/3 to 1/9, we're just going to multiply by 1/3. So R is equal to 1/3. So our recursive equation would be AN equals the previous term and then times the common ratio. So just times negative 1/3. And then our explicit equation is A sub n first term, so negative 1/3 times the common ratio, and then the common ratio to n minus 1, just like that. Okay, so to find the fifth term, I'm going to use the explicit equation because we don't know what the fourth term is, although we could figure it out. But I'm just going to use the explicit equation because we have it set up already. So we're going to take negative 1/3 times negative 1/3, and then we're going to put 5 in for n because that's the term that we want. So 5 minus 1. So this ends up being negative 1/3 times negative 1/3 to the 4th, which is equal to negative 243. Just like that. Pretty simple. All right, for the second one, for this one, we need to remember exponent rules really quick. So if you don't remember, if you have ax times, sorry, what? Oh, no, I thought you said something.
Anything.
Okay. It must have been the audio or something weird.
Gotcha.
Okay, so if you are multiplying two exponents together, really you are adding the exponents. So remember that as your exponent rule. Okay, so for this one, to find our common ratio, to get from 10 to the negative third, and then to get the next term in the sequence, which is 10 to the negative 1, just looking at those exponents. So if we just want to look at negative 3, negative 1, 1, 3, because I know that we're adding a number to those, I can see that negative 3 to negative 1 is just 2. This is also 2, and this is also 2. So our common ratio is going to be 10 squared.
Right. If you're feeling fancy, I mean, you can always take the second term, 10 to the negative 1, divide it by 10 to the negative 3, and then just use your exponent rules to simplify.
Yeah.
Or just use your calculator and it will tell you 100, which don't use 100, use 10 squared because everything is base 10. So if you don't remember your exponent rules, just set it up. Second term, divide by first term, simplify, that's your ratio.
Yep. Cool. All right, so again, let's write the recursive equation. So our recursive equation for this one is going to be an, and then the previous term, which is denoted an minus 1, times our common ratio, which is 10 squared. Nothing too fancy. And then our explicit equation is just going to be an is equal to 10 to the negative third because that is our first term in our sequence. And then we're multiplying by 10 squared. And this is all, oops, I'm gonna move this down so that we can, sometimes I overestimate my ability to write small. Okay, and this is all to the n minus 1. Cool. All right, to find the fifth term in the sequence, we actually know what the fourth term is. So we could use our recursive equation to do that. So might as well. So let's do a fifth is equal to our previous term. So our previous term would be a 4 times 10 squared. And we know that a4 is 10 cubed times 10 squared. So our next term would be 10 to the 5th. Just like that.
Yeah, perfect.
Yep. That's about all I have. I do have the blank homework below if we want to go over a couple homework problems.
Yeah, let's just do one from each section.
Cool. Okay. let's look at, let's see. Ooh, we've got some big numbers. Okay, let's look at number 1 just for sake of discussion. Okay, so let's look at number 1. Okay, so number 1, we're asked to find the common ratio, the 10th term, an explicit rule for the nth term, and then the term named in the problem. So let's find the common ratio first. So R for this one would be 2, because we're just multiplying by 2 every time. So -2 times 2 is -4, -4 times 2 is -8, -8 times 2 is -16. Okay, so then our explicit equation for this one is going to be an is equal to the first term, so -2, and then we're multiplying by our common ratio, and then that's all to the, or the common ratio is to the n minus 1, just like that. Okay, so our 10th term is going to be -2 times 2 to the 10 minus 1, which is going to simplify to -2 times 2 to the 9th. I'm going to use my calculator because I don't know what those are off the top of my head. And that's going to end up being -1024. Okay, and then the term named in the problem is A15, so we're just going to do the same process but with 15. So -2 times 2 to the 15 minus 1. So this is -2 times 2 to the 14, and that's going to end up being -32768.
Cool.
Yep. And again, feel free to use your calculators because those are some gross numbers. Okay. Let's do number 6. I like number 6. Okay. So for number 6, we have to find the common ratio, and find the missing terms in the sequence. So let's do 100 divided by 4 first, because we need to find lost my train of thought. Sorry, guys.
Yeah, what we totally multiplied by, right? Like, so 4 to 100, how much did we multiply by to go from 4 to 100?
Yes. Sorry, my mom is also working from home and she distracted me over there. Made me lose my train of thought. Okay, so then to find essentially what our common ratio would be, we're gonna take the number of hops, I guess, that we need to fill. I don't know how else to explain that, but so for this one, it's gonna be 1, 2 hops, because we're going kind of 2 spaces that we need to fill, I guess. So 1, 2. And that number of hops is going to go into our square root. So you're going to put it on the outside of your square root. So for this one, we're just taking the square root of 25. So whatever you're totally multiplying by, that's going inside the radical, and then your number of hops goes on the outside. And of course, the square root of 25 is just 5. So to find, I guess this is plus or minus 5. So our common ratio is plus or minus 5, which means that our missing term is plus or minus 20. And we don't know if it's positive or negative, so you do need to put the plus or minus there, because remember, a square root can be positive or negative, so that does need to be a plus or minus 20.
Cool.
Okay. And then I'm going to do the last problem just because it was straight down from number 6 and I don't have to scroll over. Okay, so remember, this is just a working backwards problem. So we're using the information provided to find the number of the given term. So let's figure out what our common ratio is for this one. So remember, we can take the second term divided by the first term. So let's do that really quick. So let's do 90 divided by 100. And order does matter because if you do 100 divided by 90, you're going to get something different than 90 divided by 100. So remember to do the second term divided by the first term. And 90 divided by 100 is 0.9. And that would be R. So that's our common ratio. So then to write our explicit equation, we're going to take AN equals our first term, so 100. And then we're going to multiply it by our common ratio to the n minus 1. Okay, so to find AN, you're just going to take 3.0903 and you're going to stick it in for AN. So you're just going to write 3.0903 and you're going to set it equal to 100 times 0.9 n minus 1. So the first thing we need to do is divide by 100. So we're going to take 3.0903 divided by 100. And we're going to get 0.03003. Okay, so then to do the log rules, we are going to, we need to turn this into a log. Yep.
Yeah, remember guys, anytime you have an exponent that is a variable and you need to get it out, like we do here, you have to use log rules.
Yep. And this one is, the n minus 1 goes on. Why can I not remember my log rules?
So it should be n minus 1
equals. Equals, that's right. I knew that.
Base 0.9 of 0.0309. Yeah.
Yep. I promise I know my log rules, guys. Okay, and then from there, we can just plug that log into our calculator and subtract 1. So let's do that log.
And remember, if you guys have one of the nice calculators, you can just use your calculator. You just go math, alpha, math, and that'll be your change of base formula. If you don't have one of the fancier calculators, you just hit the log button, which is just normal base 10. Then you type in the thing on the top, so the 0.030903 divided by, and then you hit that log base 10 again, and you do 0.9. And then you should get your answer.
Yes. And for sake of writing, I'm going to round to 33 just to make this nice. And so then from there, we're just solving for n. So n is going to equal 32.
34.
34, yes. Because you're adding. Yes. Cool.
All right, good stuff. Well, I hope that was helpful for you guys, and we will be back tomorrow to do another video. It should be shorter tomorrow because I think it's just mixed practice, but we want to at least do like one from each kind of section or type on your homework. We're also doing the live stream tomorrow at 11 o'clock via Zoom, so hopefully you guys tune in.
And the link for that is in Schoology, I believe.
Yeah, links.
Yeah.
In Schoology. And
I'll put the link to this YouTube video in the notes as well.
All right.
If you guys did that yesterday, it was also in the notes for yesterday. Cool.
All right. We will see you guys tomorrow. Bye.